In the previous lesson, we talked about building the equation from a graph or the table of values of the linear relation. But in this lesson, we're essentially going the other way. What we're going to do is we're going to start with the graph of a linear relation and we're going to build the equation. Now, in order to build the correct equation, we need to remember that the equation of a linear relation is written in the form of y equals mx plus b. So hopefully remember that m is representing the rate of change and b is representing the initial value or the vertical intercept. So what we're going to do in order to graph the line is we're going to use those two values to draw plot points, and to graph a line you essentially need 2 points and then you just connect the dots. But if it's possible, we're going to provide a few additional points because that will make our line more accurate. Okay, it's not that it's wrong with just 2 points, but it is easier to graph a line with 3 or 4 points. So our strategy is we're going to use our vertical intercept, and remember the vertical intercept is represented as b. So if you need a hint, let b represent or stand for the word beginning. Okay, so b stands for beginning and m tells us how we're going to move in order to plot the others. Okay, so B for beginning, m for move. Alright, so y equals 2x minus 3. So I added the scaling for my x and y axis, labeled my axes. So beginning, so b is for beginning. That tells me how or where I'm going to plot my first point. So since my vertical intercept is -3, I'm going to plot that point right there. Okay. And then how am I going to move on this Cartesian plane? How am I going to move and plot the other points on this line? So hopefully you know that 2 is exactly the same as 2 over 1. Now why would I write 2 as 2 over 1 instead? Because once I've written as 2 over 1, I can see the rise and I can see the run. Okay, so the rise is 2 and the run is 1. So 1, 2. So from my point that I plotted from the vertical intercept, I'm going to use the rate of change to tell me how I'm moving on the Cartesian plane. 1, 2, 1 over. 1, 2, 1 over. So B for beginning and M for move, right? I'm moving based on what the rate of change tells me to do, what the rise is and what the run is. 1, 2, 1 over. So I gave myself 4 points and I'm going to connect the dots now. Okay, so before I start graphing this line, I'm going to write -2 over 1. Once again, for the same reason I did before, I just want to give myself the rise and the run. So B for beginning, M for move. I'm going to plot the point, the vertical intercept. Okay, that's where I'm beginning, and now I need the other points, so I need to look at how I'm moving on the Cartesian plane. So the rise is -2 and the run is 1. So I go down 2 instead of up 2 like I did in the first example. So down 2, 1 over. That's how I'm going to move. That's what the rate of change says. Down 2, 1 over. Okay, so I have 3 points. You can follow this pattern and give yourself an additional point if you want. And by the way, you know your points aren't correct if you grab your ruler and you don't form a line. Oops, that was not very good. And that's why the more points, the better. It increases the accuracy. Okay. Let's try 1c, y equals 3/4 x minus 2. Beginning is -2, that's my vertical intercept. And then I'm going to rise of 3. So this one I don't need to put the 1 because I actually have a denominator of 4. So rise of 3 and a run of 4. 1, 2, 3. 1, 2, 3, 4. If you want to give yourself an additional point, actually this one doesn't work very nicely. It's gonna, I could put it here if you want. on the edge of the grid line. All right, connect the dots. So once again, M for move, B for beginning or begin. Where you begin and how you move to get to the other points. Okay, -1/2 of 4, so I'm beginning at 4, and the rise is -1 and the run is 2. So down 1, 2 over. Down 1, 2 over. And that's it. So in this lesson, the big idea is to build the graph from the equation of the linear relation. In the next lesson, we're going to put everything all together. We're going to talk about the different representations of a linear relation and how to go from one to another, and answer word problems involving linear relations.